Welcome back to the channel. Today we are building a inline Powerpole voltmeter. Basically, this small little unit with a 7-segment display on it will tell you the power or the voltage of your battery. You put it somewhere in between your battery and the radio, and it will show you the current voltage of the battery. This is good so you can pay attention to the state of charge of your battery, so you get a better idea of when the battery is running low. Like in this example, I can tell you this is fairly full. It shows 13.3 volts, but I have a rather depleted battery here as well. We put that in and we will see 10.3 volts. Running radio with this one is probably not very smart, neither for the battery nor the finals in the radio. So stick around, I'll show you how I designed this thing in FreeCAD, 3D printed it and built it, and how you can build your own. I'll quickly just show you how I drew this up in FreeCAD. Start by drawing out the rectangle that will be the size of the box, and you extrude that to the required thickness. Then you draw the size of the Powerpole connectors and you cut them away. And in the same way you draw the size of the room in the middle where the cables will be, and you cut that away as well. You draw the 2 circles where the screws go and cut them away, and I will use a chamfer tool to remove a little bit so that I get a counter bore on the bottom, so that the screws will be inside of the unit, not sticking out. Next up, we do some chamfers around the edges of the piece, and finally we do the protrusions and the notches where the Powerpole connectors will go. For the top unit, that's pretty much the same thing. Draw the outline of the piece and extrude it to the required thickness. We draw the opening for the display and cut that away. And also we draw the little recess with the room for the PCB and cut that away. Then we draw the 2 holes where we'll put the heat set inserts and cut them away. These do not go all the way through. And finally we do some chamfers on the corners as well. It's time to send this off to the 3D printer and see how it turns out. We will need 2 sets of Powerpole connectors. So that's 2 black, 2 red, and 4 actual connectors. You will need 2 pieces of power wire. These, well, basically as thick as will fit in your Powerpoles. I think these are 1.5 square millimeters, which should be plenty sufficient. Cut these as close as possible to 45 millimeters. That's going to make it a lot simpler to assemble. And also 2 of the thinnest wires you can get. I'm not sure about the dimensions of this, but make sure they're about 5 centimeters long. That should be all right. In addition to that, you will need 2 14 millimeter M2 screws. And if you want to make this look nice, make sure that they are, not quite sure what that's called, but these type that you can put in countersunk holes, so that they will be flush or below the surface of the surface you're screwing into. So 2 14 millimeter M2 screws. And one of these voltmeters. This is a 3-digit voltmeter. From you can get them from eBay, from AliExpress, probably other places in China, probably also Amazon. It's not a particularly accurate meter, but good enough for our use, which is just keeping track of the voltage of our batteries running into a ham radio transceiver. And lastly, of course, you will need the 2 3D printed parts. I've printed mine in PETG. You could probably get away with doing this in PLA, but if you're going to keep it outside, then PETG or some other sun-resistant material is probably preferable. Let's get building. First step, we'll be inserting the heat set inserts. That's a little bit fiddly. It helps to have a tool like this. Basically, what I find is that if I just place it on the tool and then align it with a hole and then carefully sink it into the plastic, that works well for me. Also, it helps to have tweezers to hold them. One is one, and let's get the next one in. Is that aligned? Yeah, I think that's nice. And slowly, like so. Let me see if we can get a close-up of some more light on it, maybe. Yeah, that looks pretty all right, if you ask me. Next up, we'll remove some isolation from the power cables. To make this as easy as possible, you will want to remove exactly 7 millimeters of isolation on either side of the 45 millimeter power cable. And yeah, doing that with a scalpel helps. That was probably not so much in frame, but let's see if I can do the next one a little bit better. Twist the ends, and then the other side, exactly 7 millimeters, and remove exactly that amount of insulation. That's going to make sure that there's not too much cable stuck in between that you have to work to make room for inside the device for building. See, that was that one, and same for the negative wire. I find using a ruler and the scalpel as a marker to first to measure and then to cut. Find that to be a simple way of doing this precisely and repeatably. See, and the last one, once again, 7 millimeter exactly. Should be it. And we twist the ends on those as well. For the thin wires, just getting approximately 7 millimeters off one end, and we'll do the other end later on. Cables as thin as this, I find it easiest to do that with my teeth. That's probably not healthy or good for my teeth, but it's very functional. We'll tin the ends. I find when soldering Powerpole connectors, it's important not to get too much tin on the wires, because if you do, they're not going to fit into the openings on the small clips on here. So just getting the right amount of solder on the wire ends. Something like that. And once again, having the flux on the wire before you start actually helps quite a bit to do this smoothly. And of course, copper being an excellent conductor of heat, this is frying my finger. Let's see, can we manage? I think that's sufficient. Let's do the other one as well. Looks good. And the last one. Yeah, that looks good too. For the two cables going up to the instrument, it's not really that important. Just get some tin on there, so they will be easier to solder. Let's see. Here we go. We start by connecting the power pole plug with both the sensing wire and the power wire. Just stick them nicely in like so. and just apply heat to the actual connector until it's hot enough that solder will melt inside it, and then you just feed maybe 5-6 centimeters of at least of this thickness solder. If yours is thicker, you have to supply less, and if it's thinner, you have to supply more. But what you don't want is to put so much solder in there that it starts bubbling out in the front. That will be bad. Try to align it so that it's straight as possible, and of course make sure they're both in there, and leave that to solidify while you do the same thing on the next one. Sensing wire and power wire into the connector. Let's see. Apply heat. And we'll wait patiently for it to heat up so that solder will melt inside the connector. And then we just fill it up. But not too full. Something like that. Once again, try and line them up. And leave to solidify. By the time you're done with that, this is probably set, so you can continue on the next one. The way these are going to work is you're going to have a black. Let's see, we're going to have the black connector going straight through to the black connector, and the red connector going straight through to the red connector. That means that they will be on in opposite orientations. So, looking at this, when this is facing that way, that means we have to turn it over like so before touching the other one in the same direction. So you should see now that they are facing in opposite directions, the little bulge on the Powerpole connector. So same procedure, we'll just heat it up, wait. I don't know if I'm actually built for waiting patiently, but with the amount of patience you can muster. And when it's warm enough, once again, we fill it up with solder. Try and make sure that these face in opposite direction as perfectly as possible. And we can do the red one while that one sets. Let's see. So that way, and that way. Looks about right. More heat, more patience, or lack of it. Come on. There we go. And fill it up as best as we can. And try to align them. I think that's good enough. It's gonna have to be. That's good enough. Next step, of course, will be to insert them into the casings. I find it easier to do with a small flat screwdriver. Just make sure we can figure out the right way, because if you try to force them in the wrong way, you're probably just going to bend the metal part, and that's going to break it. Let's see, we can do the same thing with the red one. Once again, find the correct orientation, put it in there, and push it into place with a small screwdriver. I always I always put these in the wrong order, so whenever I need to decide which one is on the right and which is on the left, I always find a reference, and I try to put them onto the reference like so, and that way I know I've put them in the right order. So, wasn't too hard. That was half of it done. We will do the same thing on the other side. Figure out the correct orientation. Put it in there, and nope. Just push it down till it locks. Same with the red one. I think maybe we should put this on like so first. Put you in there, and down you go. And with that, we have the electrical connection ready to go. So, as we need to get ready to insert these, you will see that on the one side you have this little notch, and inside of the other we have this little protrusion. This is of course to match, the notch is of course to match this one, and the small protrusion in here will fit into there. That's to hold them nicely and securely. So what you want to do is bend it a little bit, slide it in from one side. Make sure not to pinch these small sensing wires. Put it in, and this one of course we can't put in from this side, but there should be enough room here that you can actually just put it like so, and after that you should be able to just push it into place with a little bit of luck, like that. And we see we still have a little bit more cable than we needed, which I guess is better than the alternative. So just try and bend these in some sensible way, so to take up the slack. We'll also be able to push these in before we put the final screws in. Next up, we will make the top part, which will hold the voltmeter. We'll start by removing these wires. You may be able to use them, but I think they're so thick it's difficult to fold them up onto into the little space in the bottom part. So I prefer to just remove them and use the thin wires instead. Also, I'm guessing this is optional, but I don't like the plastic cover on top here, so I will just remove that. And we should be able to fit this nicely into the opening here. Nope, we forgot one thing. Let's see if I can show you these. Come on, focus. Yeah, these pins from the display. We should trim them off as much as possible. Again, for them not to cause any issues in the very limited space down here. Then we can place it into the top part, push it all the way through. You should see that it's flush with the top. Then we can go on and fasten these sensing wires. Let's see, and here the black wire should go on the corner and the red wire should go just slightly in from there. So start by cutting them to an about appropriate length and remove just a sliver of isolation. The reason I'm not removing more is that usually when you tin the edges, when you tin the ends, the isolation will tend to creep back because it melts. And it did once again. You don't want these too long, so just cut them as short as you are comfortable having them. And we'll get ready to solder them onto the voltmeter. I find this is easier if I just bend them downwards like so, and then we can let's see if we can you can see this. You just heat up the solder blob on the solder pad, place it in there and make sure that's warm as well, and that should be it. That should be the negative wire. Do the same thing with the positive wire, fold it over, create a little hook, and Come on. Heat up the solder pad. Just stick it in there and make sure the wire is hot as well so that it melts and sets. At this time, I usually think it's a good idea to test that it works before we put the rest of this thing together. So I will connect up a battery and insert it, and we will see. This says, I don't know how well this turns up on camera, but it says 13.3 volts. Very nice, so we know it's working. We will continue to put this together. Now, I think I said you needed the M2 by 14 millimeters. That was incorrect. These are M2 by 16 millimeters. You can make it work with 14, but it's going to be a lot simpler with M2 by 16 millimeters. And to put this together, what you'll need to do is try to find a way to fold the measurement wires in such a way that they will not get in between the two pieces when you put them together. And just hold it the way it's supposed to be and press the power poles flush, because these screws go through the hole in the power poles, and that's so you need to push it in and make sure the screw is entered at least. This would probably be a lot easier with an electric screwdriver, but hey. And the other one going through the power pole, and like so. And seeing as these are heat set inserts, the thing now is that you have to fasten this the correct amount, not too much and not too little. And sadly, I can't tell you how much that is. So you will have to, what I try to do is just tighten it until there's no visible gap. And or at least till there's no big visible gap. I think we have it. And that's it. That's the inline Powerpole voltmeter. Let's give it one more go. So to use this, you just insert it in between your battery and your radio. And let's see. And it will tell you 13.3 volts. And of course, it doesn't matter what side you put the connector into, and you get the output on the other side. That's it for this time, I think. If you enjoy this sort of project, I would encourage you to subscribe. I'll do all sorts of projects having to do with basically anything vaguely related to radio. I will do. If you liked the video, please consider giving me a thumbs up. If you have any comments on how I did it, or other ways of doing it, or well, basically any sort of comment, then please leave them in the comments below the video. I try to read and reply to any sensible comments, at least. Other than that, I'll say until next time, thank you so much for watching.